For today's video, we are going to discuss all about Module 6, finding the nth term of the geometric sequence and geometric means. Lesson 1, finding the nth term of a geometric sequence. In finding the nth term of the geometric sequence, so the exponent of r is less than 1 of the subscript of a. The subscript of a refers to the placement of the term, which is denoted by n. Therefore, using these variables, we derive the formula a sub n equals a sub 1 times r raised to n minus 1. So we have here the general idea. The formula in finding the nth term of a geometric sequence is a sub n equals a sub 1 times r raised to n minus 1, wherein your a sub n is the nth term, your a sub 1 is the first term, your r is the common ratio, and your n is the number of terms. To learn more about on how to find the nth term of the geometric sequence, we have here some examples. So find the 7th term given a sub 1 is 5, your r is 2, and your n is 7. So we have here the solution. So a sub n equals a sub 1 times r raised to n minus 1. Your a sub n or your n is 7, substitute that on n, and then your a sub 1 or the first number in the term is 5 times your r is 2, your n again is 7 minus 1. So a sub 7 equals 5 times 2 raised to 6. We got 6 because we subtracted 7 into 1, so that the answer is 6. So a sub 7 equals 5 times 64. We got 64 because we multiplied 2 6 times. So 2 times 2 times 2 times 2 times 2 times 2 is 64. And the last is 5 times 64. Therefore, the nth term or the 7th term in the geometric sequence is 320. For the second example, we have here, find the 10th term in the sequence. So we have a sub 1 equals 5, your r is 2, your n is 10. So substitute all the values. So your n is 10 equals your a sub 1 is 5 times your r is 2 raised to 10 minus 1. Your n is 10, so 10 minus 1 is 9. And then a sub 10 equals 5 times 512. Again, we multiplied 2 9 times to get 512. And 512 times 5 is 2,560. Find the specified term of the given geometric sequence. So we have here number 1, 1/2, 2, and 8. Find a sub 6. To solve for the unknown term, identify first the given values. The first term or your a sub 1 is 1/2, and the unknown term is the 6th term. So the value of n is equal to 6. Now let us find the common ratio. In order to get the common ratio, so we have here the formula. R equals a sub n divided by a sub n minus 1. So a sub 2 divided by a sub 1 equals, your a sub 2 is 2 divided by your a sub 1, which is 1/2, will give us 4. The given values will then be substituted to the formula in finding the nth term of a geometric sequence. So we have here the given, your a sub 1 is equal to 1/2, your common ratio or your r is 4, your n is 6. So we have here the unknown, your a sub 6. So using the formula, a sub n equals a sub 1 times r raised to n minus 1. So your n is 6, substitute that. So a sub 6 equals your a sub 1, that is the first term in the sequence, which is 1/2. So 1/2 times your common ratio 4 raised to 6 minus 1. So a sub 6 equals 1/2 times 4 raised to 5. We got 5 here because we subtracted 6 into 1. So that is 5. And then we're going to multiply 5 times the 4. So 4 times 4 times 4 times 4 times 4 will give us 1024, and then multiply that into 1/2. Therefore, the unknown term in the sequence is 512. So we have here lesson 2, geometric means. The given terms are the first and last terms. These terms are called the extremes, and the term or terms in between, so sa tunga, are the extremes are called geometric mean or means. In geometric sequence 2, 4, 8, and 6, the number 4 and 8 are the geometric means of the extremes 2 and 16. So if we say extremes, the first and the last term in the sequence. If we say geometric mean or means, that is in between. So let us first define what is meant by common ratio. So common ratio refers to the ratio of two consecutive terms. So we have here the formula, R equals A sub n divided by A sub n minus 1, same through as A sub 3 divided by A sub 2 and A sub 2 divided by A sub 1. Therefore, we can equate A sub 3 divided by A sub 2 is equal to A sub 2 divided by A sub 1. This can be our basis in finding the geometric means. So we have here A sub 3 divided by A sub 2 divided equals A sub 2 divided by A sub 1. So let's go back to the problem 12 and 3. The first term is 12 and the last term is 3. Now let us substitute the value. Your A sub 3 or the third term in the sequence is 3. Your A sub 2 is unknown. So let's not put any number on A sub 2. Your A sub 1 is 12 or the first term in the sequence. Now let us cross multiply. 3 times 12 is 36. A sub 2 times A sub 2, that is square root of A sub 2 equals square root of 36. The answer is, your A sub 2 is 6. So this is the formula on how to get or to find the common ratio. So we have here your R equals n minus k square root of A sub n divided by A sub k. Your n is the number of terms. Your k is equal to 1 since it is the first term placement. So every k is 1. Your R is the common ratio. Finding the missing terms in the following geometric sequences. So number 1 is 3 and 45. We're going to find the middle term. To insert a geometric mean, let us first identify the extremes and number of terms by substitution. So we have here 3 terms. Your 3, the second number, which we are going to find, and the third one is 45. So A sub 3 divided by A sub 2 equals A sub 2 divided by A sub 1. By substitution, let us substitute the value of A sub 3, which is 45. The A sub 2 is unknown, so we don't need to write any number in that. Your A sub 1 is 3. And then we're going to cross multiply. So 45 times 3 is 135. A sub 2 times A sub 2, A squared. Yeah, A sub 2 squared. So let's use the square root. So square root of A sub 2 equals square root of 135 or 3 square root of 15. Therefore, your A sub 2 is 3 square root of 15. For the second example, there are 2 geometric means needed in this problem. Let us identify first the extremes and the number of terms. So the extremes or the first term is 2 and the last term is 250. There are 4 terms in the sequence because we have here 2 blanks. So using the formula on how to find the common ratio, we have R equals n minus k times square root of A sub n divided by A sub k. So your n is 4 because we have 4 terms, minus 1. Times square root of A sub 4 because your n is 4. So substitute the value of n, which is 4. Your k is always 1. So A sub 4 is 250 divided by A sub 1, which is 2. So 250 divided by 2 is 125. The cube root of 125 is 5. Therefore, the sequence is 2 times 5 is 10. So the second term is 10. 10 times 5 is 50. So the third term is 50. And 50 times 5 is 250. So we are now on Module 7, Geometric Series. So here is the formula in finding the sum of the first n terms of a finite geometric series. If we say finite, it has an end. So we have here the formula S sub n, your S stands for sum, equals a sub 1 times 1 minus r raised to n divided by 1 minus r, wherein your S sub n is the sum of the first n terms, your a sub 1 is the first term, your n is the number of terms, and your r is the common ratio. To learn more about this lesson, I have here an example. Find the sum of the first 5 terms of the geometric series 7, 14, and 28. So, solution, we have here your a sub 1, or the first number in the sequence is 7. Your n, because we are looking for the first 5 terms, so that's why your n is 5. Your ratio is a sub 2 divided by a sub 1. Your a sub 2 is 14 divided by your a sub 1, which is 7. So 14 divided by 7 is 2. Now let us substitute the given values in the formula. So S sub n equals a sub 1 times 1 minus r raised to n divided by 1 minus r. So that is our formula in finding the sum of the geometric series in the finite sequence. So your n is 5, so S sub 5 equals your a sub 1, or the first term in the sequence is 7 times 1 minus your r, which is 2. 2 raised to 5 will give you 32. Why? Because we multiplied 2 5 times. 2 times 2 times 2 times 2 times 2. And then we're going to subtract 1 minus 32. The answer is negative 31. Why is it negative? Because the sign of the bigger number is negative. So negative 31 times 7, that will give us a negative answer, which is negative 217. Divided by negative 1, so negative times negative divided by negative will give us positive. So that's why our sum for the first 5 terms in the geometric series is 217. Another example we have here, find the sum of the first 7 terms of a geometric sequence whose first term is 3 and the common ratio is 4. So here, the common ratio is already given. Your a sub 1, or the first number in the sequence, is 3. Your n is 7. Why? Because we are looking for the first 7 terms of a geometric sequence. So let us now substitute all the given in the formula. So your S sub n will be S sub 7 equals 3 times 1 times minus 4 raised to 7 divided by 1 minus 4. So we got 16,384 because we multiplied 4 7 times. That will give us 16,384. And then we're going to subtract that into 1. The answer is negative 16,383. Negative 16,383 will be multiplied to 7. The answer is negative 114,681. And then we're going to divide that into negative 3. The final answer is 38,227. We got positive here because if we're going to divide negative times negative, that will give us a positive. Lesson 2, Infinite Geometric Series. If we say infinite, it's continuous, unstoppable. So we have here example, we have 1 plus 1 half plus 1 fourth plus 1 eighth plus 1 over 16 plus 1 over 32, and we have here the ellipsis. So the 3 dots is ellipsis, is called ellipsis. Ellipsis is a set of 3 dots that indicates infinity, means no end. So we have here the formula on how to find the sum of the infinite geometric series. So your sum to infinity equals a sub 1 divided by 1 minus r. So we have here an example. So solution, your a sub 1 is 1. Your common ratio is a sub 2 divided by a sub 1. So your a sub 2 is 1 half. Divided by 1 is 1 half. Now let us substitute these values in the formula. So we have here the sum of the infinity equals a sub 1, where a sub 1 is 1 divided by 1 minus your common ratio, which is 1/2. So 1 divided by 1/2 is 2. So that's all. Thank you for watching. See you again in my next video.